Welcome to TPM's 3-Minute Thursdays. My name is Robbie Hoyler, and today we're going to be talking about thermal simulations and how to find data such as conduction and convection heat transfer coefficients. On my screen I've got a heat sink, and for a lot of products you can tell on the package if there's a certain wattage or a power provided by that product, and you can kind of tell how much heat could potentially be generated by that product. But a lot of times they really don't give you a lot of information about how hot that product is going to get if it's in open air or if it's in an enclosure. So that's why we use products like SOLIDWORKS Flow Simulation and SOLIDWORKS Simulation Professional to determine these values. So if you're trying to determine how hot a heatsink is going to be in its environment, simulation is a good way to do that, but there's a few tricks that you need to know to obtain the right values and the right information. If you have SOLIDWORKS Flow Simulation, you can actually import the convection data from that simulation into your thermal study inside of SOLIDWORKS Simulation Professional. You can click this box, click the study, and it will actually create the thermal loads for convection for this heatsink. More often than not, you don't have access to that information, so you'll have to actually add convection manually by clicking on some of these faces. But then, when you get to the convection coefficient, a lot of people don't necessarily know what value goes inside of this box. You can make a pretty good guess by looking in a heat transfer book, or you can calculate it. I'm going to share with you some resources. The engineeringtoolbox.com is a very nice website. It'll find a lot of different engineering equations you can use to kind of check some of these values inside of your designs. One of the ones I would really point you guys towards is the conduction tables inside of the engineering toolbox. So we have a list of thermal conductivities for common materials. And we also have a convection heat transfer, and I would point you guys down to this equation here to calculate the convective heat transfer coefficient for air. Now, if you look at inside of a heat transfer book, you'll see some of these. Free convection for air, gases, and dry vapors is anywhere between 0.5 and 1,000. Well, if you put that in a SOLIDWORKS simulation as 500, it may or may not be the right value. So if you know the velocity of the air moving across your heat sink, use this equation here to calculate that. And that way, when you go back to SOLIDWORKS simulation, you'll have an accurate number and you'll get a more accurate simulation. The last resource I want to share with you guys is that inside of the SOLIDWORKS simulation material library, if you're inside of a thermal study, you can see in red what SOLIDWORKS simulation needs from the material to get an accurate material for the simulation. So in red, I need the mass density and I need thermal conductivity. In blue, specific heat would be something that is nice to have, but it is not a necessity. If you go to the tables and curves, you can actually check thermal conductivity versus temperature of this material. Now, in this case, I don't have anything inside of my dialog, but if you have that from the manufacturer or you need that information to get an accurate simulation, another resource I would share with you guys is MattWeb. So here I'm making this heat sink out of copper. I can go and find the material copper inside of MattWeb, and this is a very, very useful and accurate engineering database for materials. It's very commonly used in industry. And I could come down and see that I have a 385 watts per meter Kelvin thermal conductivity for this material. But you can also see that it changes with temperature. So you can see that people have put different temperatures in here, temperatures that have been tested, thermal conductivities that have been tested in a laboratory. So MattWeb is a very, very useful database to make sure that your material that you're actually using in your simulation is the right one, because 390 is what I have inside of my thermal conductivity for copper in SOLIDWORKS, but that may or may not be the right conductivity. So you need to check this every time you use a different material. If you can get the material information from the manufacturer, that is going to lead you with a more accurate solution. This has been TPM's 3-Minute Thursdays. Thank you, and we'll see you next time.